Live. Hello, everybody. Make sure everyone can hear me. No echoes. No, nothing's wrong. Looks like everything's good. Everything's good on your end. Alrighty then. Well, last week we were off. I do want to mention for some of you guys who have been following this chat for quite some time, we had Norman the guinea pig. He unfortunately had passed away, so we kind of wanted to take a step away. But he was 9 years old. But I wanted to mention him because, he was an important part of our family, that is for sure. And so we just wanted to say we miss Norman quite a bit. And of course, we had a very impressive remnant storm from Ophelia that produced quite a bit of rainfall last weekend and produced unsettled conditions all throughout the start of the week. Everyone knew about it except for the Mets, apparently. I don't know what happened there, but if any of you guys who still follow baseball, I know for some of you Philly fans, I know out there definitely, of course, do go into the playoffs. Congratulations. I don't know how the Mets field crew didn't know it was going to be raining, but everyone else knew. I mean, everyone. I don't know. But with that remnant low, we finally cleared out today, but it's coming back in another form. So I want to talk about that because there's a lot of model guidance out there right now that's kind of a bit over the top. And it was the NAM guidance, as always, doesn't fail to impress, providing some very impressive rainfall totals over the northern mid-Atlantic for tomorrow evening on through Friday morning. We're talking about like 4 or 5 inches of rain. Seems a bit much, but there's a but. There are a few isolated locations that could be pushing to 3 inches on the immediate coast. I'm going to explain why. And then, of course, a lot of data is starting to come in for the winter. So we have a lot of stuff to talk about. I'm sure I'm already getting people asking about the winter, what's going to happen. As you all know, we will have our winter forecast issued towards the end of October, which is only a couple of days away till we get to October 1st. I like to wait to the end of October, mostly because then we get a full idea of the snow growth in Siberia. And also we get a pretty good idea on the evolution of forcing mechanisms. And one that's really catching my eye is in the Pacific, so we'll definitely talk about that. But first things first, let's talk about what is going on with the observations with our inverted trough. Now, this is the surface map from WeatherTap. And of course, this is what's left of Ophelia. It's now an extratropical storm. And this is the remnants, and it's basically buried within the subtropical jet stream with plenty of moisture. Of course, there's our high pressure system that built down and finally produced sun after several days of overcast skies, drizzle, and just rather depressing weather. And then we have this feature here. This is a feature in the polar jet stream, and it really shows up really nicely in the water vapor satellite picture right here. So what is happening here? Some really cool processes are starting to interact here. And first thing we have to do is define the pieces before we start to dive into the models and get all excited and start pulling up different features like the NAM precipitation and the GFS precipitation maps and all this stuff. So on the water vapor satellite picture, we have our strong feature in the polar jet stream. Now this feature is getting cut off from the rest of the polar jet stream because of this feature right here. Let me zoom in here. This is a deep trough coming into the west coast. The reason why this is important is that it kind of gives us an idea on the entire environment that we're going to be dealing with in this storm. So with the trough building into the west, we know a couple of things about the polar jet stream. One, any feature developing along the coast is going to get forced east pretty quickly. And two, there's a lot of stretching in the atmosphere. More times than not, this leads to just pretty much Any storm that develops, the exit stage left, and not really much of an issue at all, and it ends up being a quiet period of weather. But every so often, when you get a vigorous shortwave like we have this one here, it can create a lot of stretching and movement in the atmosphere from the surface on up to the upper levels. And that stretching kind of acts like as if you had taffy and you start pulling it in different directions and you start creating little gaps and holes in the taffy. Well, when you do that to the atmosphere, that leads to rapidly rising air. Why? Because those gaps have to be filled, because the atmosphere is always looking for balance. So as that pulling is happening, you start to get that rapid rising and you start to get lifting of moisture. And that lifting of moisture translates to very heavy rainfall. So we have that environment set up. So we have the stretching, but we also know it's going to get kicked out pretty quickly. We also have a subtropical jet stream, and this is loaded with tons of moisture. So now we have deep moisture, we have stretching. Now all we need now is where is the location and what type of moisture are we lifting? Well, this is where we start to dive into some of the observations. So let me see, I think I got it right here. Okay, so here is the Mid-Atlantic view from the SPC. And this is the deep moisture that's starting to get pulled north. You notice this little kink here? See that little pull? Well, that is starting to get pulled northward. And what's going to be interesting is as this trough tightens and intensifies, and we start to get a new wave of low pressure developing, you start to pull in this deep moisture, and that enhances your rainfall rates. So this is why I'm a little bit concerned about the potential for intense, heavy rainfall. But is it for a long period of time? No. So again, we go back to the trough in the west. It's going to kick everything out. So we know that the timing is such that everything's moving, but we also have a lot of stretching and we have a lot of pulling. This means you can't just use one tool. You have to use multiple tools, i.e. models, but you don't take them verbatim. So how do you work out this forecast? And this is a great trial run for the winter in terms that when we're doing our winter forecast for a snowstorm and we're dealing with inverted troughs and we're dealing with storms transferring energy towards the coast or PVA, positive vorticity, towards the coast, and we're seeing redevelopment, you can't just use one tool that fits them all. You have to kind of use different features all combining together. So first we want to look at the winds here ahead of this system. This is, again, Earth.New School. This is at 250 millibars. And what do I take from this? Okay. The subtropical jet stream, positive tilt, strong southwesterly winds. Polar shortwaves being broken off from the rest of the polar jet stream. The polar jet stream is lifting northward with this ridge. This ridge is likely going to slow this feature down, create a little bit of a block. So this feature comes in, this feature wants to force it out. So this is going to kind of get squeezed out here, and you got a lot of divergence and diffluence, but a strong southwesterly wind. Meanwhile, 850 millibars. This is where things get really interesting. Easterly wind. Obviously at the surface, you're going to have an easterly wind because you have high pressure in control. But at 850 millibars, this leaves us with an interesting conundrum here. You have winds moving in opposite directions as you go up higher in the atmosphere. So we already have that stretching factor already in place in the atmosphere ahead of all this moisture transport. And the type of moisture transport we're dealing with, when we take a look at precipitable water, is pretty deep and it's close to that transport. So now you can kind of start putting the pieces together. So now when you start using the synoptic models, let's take a look at, let's see, where are my upper level winds here? Here we go. Okay. Okay, so at 250 millibars at 42 hours out, which is essentially around midnight tomorrow. Midnight, okay, from 11 p.m. tomorrow. So Thursday evening to Friday morning, right? At 250 millibars southwesterly winds, 500 millibars southwesterly winds. 850 millibars, look at that jet streak. So you have tropical moisture at the mid and upper levels, and then you have this Atlantic moisture punching in at 850 millibars. When you see this type of signal, it's not a widespread rainfall event. This is a fire hose that is marching along as the new low pressure system forms. So this is a very fast moving heavy rain event tomorrow night into Friday morning from the Jersey Shore. Let's say from Atlantic City it starts to develop, marching its way straight up. So it kind of does this, right? So you can see how that's formed on the upper level winds, and you look at the same time period in terms of the lifting parameters. Remember what I said about all that stretching and rising air? Well, there's your stretching. And by the way, your 500 millibar heights are falling, so that means more enhancement of rising air. And notice again, in the synoptic state, you have very strong lifting here. So what I'm using here with the synoptic models is that I'm finding the placement of the strongest synoptic lifting parameters. Okay, I'm using the tool that I need to use for this type of level, for this type of question. I look at 700 millibars, seeing the same thing. And you can see the 700 millibar low starting to form, and your strong lifting. Now the strongest lifting is right along the coast and over the coastal waters. Notice that theme again at 500 millibars, 700 millibars, and 850 millibars. And notice with the upper level winds here, you have some what we call vectors. So you have the vectors kind of split here. So this is an 850 millibar warm front as well. So you got some frontogenesis. So what does that mean? Basically, in basic terms, it's like a thermal gradient. So when you have that thermal gradient, you can see that popping up right here. There's your tropical moisture getting pulled northward, right? Remember I was showing that start of that kink in the observations? Well, here we are 42 hours later. It's the same signal. Pushing northward, moving up the coast. You also have a pretty good thermal gradient back here, which should enhance lifting. So, okay, so synoptically we have lifting, we have 500 millibar heights falling, you have a lot of factors coming together supporting rainfall, and you have a signal of a strong 850 millibar jet suggesting a fire hose effect. You have a lot of your lifting focused over the coast and over the coastal waters. So you know your best lifting is towards the coast. But then you have precipitable water values, 42 hours. Again, over 2 inches. Now remember with the precipitable water values, you have cooler temperatures now. So as you get cooler, your baseline for intense heavy precipitation falls because you're not able to hold as much moisture in the atmosphere. So when it's in the 80s and 90s, you can hold 2-3 inches of precipitable water. When you're in the 50s, 60s, and 70s, or 50s and 60s, when you exceed 1.5 inches, that is a lot of moisture in the atmosphere. So as you can see, that is what we're dealing with in this situation. Cooler air mass overall, because after all it is fall, and you have this moisture transport here with an intense amount of moisture right along the coast. So what should we use now? Well, let's take a look at the NAM. And what does the NAM do? Well, it starts off correctly with producing this wave of showers. This is the start of the moisture transport with the 850 millibar jet that we were using with the synoptic model, right? Synoptic means large scale, by the way. So this makes a lot of sense. NAM continues to produce this, and then it produces this signal right here. This is convected feedback error. So what you would need to produce this scenario is you would need intense lifting over this location, and you would need to have instability in the mid-levels of the atmosphere. We don't really have that in this environment. So this is why it sounds like it's more like an error, certainly producing 3-4 inches of rain away from the coast here. This would set up away from the strongest lifting. Now, when we look at this, it's important to take a look at some of the lifting parameters. So let's see what we can look at here. We want to look at the 850 millibar winds and see what this looks like. Does it line up and make sense? Okay, so where's the error that it makes? Well, right around here is taking the 850 millibar jet and pushing it inland. Why is this an error? Remember where I started off way back with the Pacific Northwest with that upper level low, pushing everything east? Why is that important? Because every synoptic model, large scale model, is suggesting that, if I find it, here we are, that our 500 millibar and 850 millibar low forms over New Jersey and then kicks out into the Atlantic quickly because everything's getting pushed east. So there is our error. We found our error in the NAM. It produces the 850 millibar jet way too far to the west compared to where the 850 millibar low is going to form. The jet streak enhances orographic lifting along the Appalachians and produces heavy rainfall. So when we understand that, then we could take the combination of the synoptic scale and the mesoscale models back here. Let me go back to the precipitation, and this is how I'm going to work this out. What do I know from the mesoscale model? The potential here for intense rainfall. I just don't like the location of it. The location of it should be over the coastal waters and along the immediate coast. And also it lingers too long. It still lifts northward, but it tries to linger a little bit too long and produces a little bit too heavy of a precipitation rate. So we take that, and then we take what's showing up here in the synoptic model. You can use the same thing with the GFS, it's showing essentially the same thing. And you study this, and what does it tell you? Okay, I'm going to pinpoint my heaviest rainfall from Atlantic City through Ocean and Monmouth County in New Jersey, up towards around Staten Island, New York City, clipping the extreme southern portions of the Hudson River Valley, Long Island, and Connecticut. I'm focusing in these areas here for intense rainfall. Most locations pushing over 1.5 inches of rain, but the key thing here is that this isn't going to be happening where, you know, you start at like 10 o'clock at night and it continues all day on Friday. No. The majority of this rainfall is happening in a short period of time. So Thursday night into Friday morning looks like a significant flash flooding event for basically central New Jersey, which exists, by the way, northeast New Jersey into New York City Metro, Long Island, southern Hudson River Valley, and Connecticut. Let's say from 8 p.m. tomorrow, continuing on as this precipitation event lifts northward. So it starts around 8 p.m. tomorrow, around Jersey Shore, marches its way northward through the evening, As you get towards the late night, it shifts into New York City, into the early morning hours, and then during the morning rush hour, just perfect for Friday, then this event shifts and focuses more towards the southern Hudson River Valley, Long Island, and Connecticut. While New Jersey just kind of has scattered showers and drizzle and just kind of raw conditions out. While this is all happening, you also have winds around 10 to 20 miles per hour, times gusting up to 30 miles per hour, especially in those heavy rainfall bands. And then behind this event, behind all of this, go to the upper level winds here, mid-level winds. As this whole thing pulls away on Saturday, in case you have anything like outdoors or anything, Saturday with a northerly wind and all this mixing on the backside of the upper level low, it's going to be pretty windy. So 10 to 20 miles per hour, gusts up to 30 miles per hour on Saturday. So don't be surprised if Saturday is a bit of a breezy, cool day with wind around with mixings with the 850 millibar jet. So with that, this is kind of what I'm expecting. And premium members, we've been working with this for the past couple of days. This is what you essentially get as a premium member. One of the features is the impact map, and it's essentially a Google map, so you can zoom in on it. So that way you don't have to ask, hey, what's going on in my backyard? You can literally zoom into it down to the street level. So in this area right here, I'm going 1.5 to 3.5 inches of rain. All right, I know it's a bit of a range, but basically what I'm looking for is most locations around 1.5, 2 inches of rain. But then we have to take into account of that NAM signal of heavy bursts here. But I don't think it's a widespread. I think it's certain spots here and there. Again, we've got the time period here with the heaviest rainfall, essentially 10 p.m. tomorrow through 12 p.m. Friday as this band lifts northward. A little bit further inland, the rain isn't as intense, so 1/2 inch to 1.5 inches. And then as you go further west, 1/4 to 1/2 inch, and way out here, 1/10 to 1/4 inch of rain. And you can see the way I have this organized here. Essentially, you can make out the band sweeping northward, right? From the southern Jersey Shore up through Connecticut and then out. So we're certainly going to have some active weather, that is for sure. But what about the winter? Because I know you guys are asking, you're wondering, and then I'm going to get to all your questions. But what am I noticing that really has my eye? How about tropical forcing? I talked about this in the long range thoughts, so premium members have a pretty good idea of where I'm going here. There is a lot of talk out there about east-based El Niños. El Niño is not going to be east-based. It's going to be central-based. And one of the signals that's strongly pointing to that direction is the overall development of convection around the dateline. This is a really important signal here. Convection helps us understand where lifting parameters are. And if you understand where the lifting parameters are, it gives you an idea of how the circulation is developing. Now, convection itself does not change the weather pattern. It's a signal. Convection obviously helps produce latent heat release, and you have that aspect going into the pattern, which of course is very important. But it doesn't tell me what's happening down the road. It just tells me, okay, we got enhancement. The storm could be stronger in the short term relative to our discussion of seasonal as opposed to week, right? So I'm seeing this trend, and it's not just this past week, but it's been months. And let me see if I can find, I know I had this data around here somewhere. Here we are. Okay. So 200 millibar or HPA vertical velocity potential around the dateline. And this is going on since going back to the spring of a constant focus around the dateline, around 180 longitude. Why is this important? Because you have rising air in the central Pacific. And that rising air helps to enhance the development of troughs in a specific location to the south of the Aleutian Islands. Why is this important? To the south of the Aleutian Islands, when you have that trough set up, it has to teleconnect to a trough in the eastern United States. It opens up, does not guarantee, it opens up the potential for high latitude blocking to establish itself in the northern Atlantic. And it reduces the chance of the polar jet stream to just run roughshod and over any type of high latitude blocking that might develop. It helps to align the subtropical jet stream with the polar jet stream. So by doing that, you enhance the potential for interaction between the two jet streams and increase cyclogenesis. What have we seen since the start of fall? Right? We've seen the polar jet stream shortwaves interacting with the shortwaves in the subtropical jet stream, one of which was a hybrid tropical system, but it's still holding the same type of theme here, which when we take a look at the water vapor satellite picture, I mean, look what we have. Polar shortwave, this shortwave. They're interacting. They're going to stretch the atmosphere. Why is this happening? Because we're seeing the convection taking place around the dateline. It sets the whole pattern in motion. Why do we know that our hurricane, let's see, what was it? The one that was everyone's freaking out about, the Cat 5. I forgot what the name was. But why do we know that wasn't going to impact the eastern United States despite everyone making videos about it? Well, because we knew we were going to have a trough in the east. Why did we know we had a trough in the east? Because we knew we had convection around the dateline. You see how this all plays out? It all is connected. So when I start to see this signal showing up, and it's not just a week, it's not just a month, it's been 2 seasons. That's a pretty strong signal. And of course, if you really want to take a look at whether or not we're seeing a shifting El Nino, this has been El Nino through this late spring and most of the summer. Notice where we are in the fall now. Again, this is towards the eastern zones. This is towards the central zones. We're seeing that shift take place. And we're seeing that more and more when we take a look at our subsurface anomalies, where you're seeing that shift getting closer to Nino 3 and 3.4 and away from 1+2. Now, 1+2 isn't just going to collapse, but I think that 3 and 3.4 are going to take more and more of a presence. Now, I do expect them to be in the strong range, so we're dealing with a strong El Nino. That means that you kind of go all or nothing here. Strong El Ninos are kind of like either a knockout punch or a continuous whiff, okay? If you look at the history of strong El Ninos in the past, if everything lines up, you end up with very impressive winters in terms of winter storm potential. But if one thing is off, like your high latitude blocking or the evolution of your polar vortex, then you can end up with a whiff. So this, again, looks like kind of an all or nothing. And of course, there are factors in the stratosphere that we do have to contend with, like all that water vapor. And what does that mean? That should lead to a cooling stratosphere. But with that cooling stratosphere, we also have, see if I have those numbers here. I know I had them somewhere. Where were they? Of course, I probably don't have them now, but the QBO is in a state of change and is basically going into a negative state. I guess I deleted it. Oh well. But basically, what that does for us is that it sets up the environment for more high latitude blocking development. Oh, here we are. So you can see the polar vortex starting to develop. And here we are. I'm sorry. Okay, so this is where I've been watching here with the QBO. Why does the QBO matter? The QBO matters because when it goes into a negative state or easterly wind, it increases the potential for stratospheric warming. Why am I interested about stratospheric warming? Well, remember what I mentioned about the water vapor and how it cools the stratosphere. So I'm thinking the stratosphere overall is going to be cold, which when you hear that, you would say, oh my God, cold stratosphere means your polar vortex is going to be strong and you're going to have strong ridges and it's going to be a horrible winter. In theory, I understand that. But the QBO isn't playing with that theme. The QBO is saying, we're going to be transporting warm air from the troposphere into the stratosphere. So basically the polar vortex is up here and the QBO is a boxer and the QBO is ready to punch the polar vortex and take it out. So while it's doing that, it starts to weaken the polar vortex. And so what we're starting to see is our polar vortex is starting to develop here. It's starting to strengthen. But we see an interesting signal here. Stretching. Why are we seeing stretching? Well, we're going into a negative QBO state. We have a lot of warm air and moisture being transported from the troposphere to the stratosphere. You're getting that punch up right there and stretching the polar vortex already. So how do we play this? Well, if you have all this moving mass, it's going to support areas of high latitude blocking. What we don't know is where and how long. And that is something I'm going to be working on over the next couple of weeks. And it takes some calculus and some studying. I'm going to be doing some research and taking a look at a lot of papers. And of course, considering the unknown, because we are in the unknown here in this factor. But you can see how all this is coming in, playing together. Now, while the stratosphere is intensifying, as the polar vortex is intensifying, what you're going to see is a lifting of the polar jet stream. And this is typical of El Niños. We're going to have a nice warm fall. It's typical. So starting actually after this week, I kind of expect generally dry conditions and warm conditions. I wouldn't be surprised to get a few days in the 80s, but don't get too used to them. It won't be the same though as well because the sun will be setting much earlier. So you have a shorter period of time to warm the atmosphere. But certainly a lot of interesting factors all playing in here. So a lot of interesting stuff all coming together here that we're going to be studying and keeping an eye on. But some of the signals we have seen this September are important. This is all happening, by the way, without much of a blocking pattern here in the troposphere. I mean, this pattern is not one of strong negative NAO type scenario here, but it is enough to make things interesting between the subtropical and polar jet streams to create this storm event. With that, let me just bring up one other thing. It's important to me. As you know, I always read a lot of books. So I have 2 climate books I strongly suggest you read. I got them, and I wanted to share them with you. This one is by Judith A. Curry. She takes the position more of we have to be concerned about climate change and whatnot, but it's not the end of the world. And then we have Mr. Dr. Michael Mann. I personally don't always agree with this gentleman, especially the way he handles data analysis. But it's important to read both books because if all you do is read whatever you happen to agree with, then you learn nothing. So always expose yourself to different points of view, different trains of thought. Even if you don't agree with them, you could find things that you might agree with that helps strengthen your understanding. And it's never a good idea to put yourself locked into one ideological group. Always read different books and read different stuff. So I got both of these off of Amazon. They're great books. I've been reading them so far. And I would strongly suggest getting both of them for, hey, the holidays. You know, we're getting to that time of year. There are various different holidays. We just had some Jewish holidays, and we're going to have some other holidays and all sorts of things, so birthdays and stuff. So definitely get them. I think you'll enjoy those books quite a bit. So with that, oh, it's already 8:35. I really went on a rant there. Okay. So with that, I am going to answer all of the questions here on YouTube, on the premium chat. And then, of course, then I'll go to YouTube and see, holy smokes, we got a lot of stuff going on here on YouTube as well. All right, that was Lee. I forgot about that. Lee. You know what? I blocked it from my mind because of a pain in the neck. That's why. Okay, so let's see what we got here. Snow is coming. Well, it can't be any worse than last year. My God. Thank you for the condolences on Norman. I took it hard. I really did. You know,
I was with him though. I was the one that he died in my arms.
I know. I think that's what bothered me the most is I kind of missed that. Not, you know, I don't know, but I miss him. I every time I wake up in the morning to go see him, I'm like, oh yeah. I just stopped breaking that. What was that bright thing in the sky today? The sun, or yeah, pretty much the sun. I'm starting to build my arc again. Yeah, that's probably a good idea. Hope we don't see those long, lengthy jet streaks at 250 millibars in the winter like the one over Asia and most of the Pacific right now. Is the current jet streak related to the polar vortex maturation? Yes, it is. It's all part of the process. In El Nino years, what happens, and again, we're dealing with a bit of a unknown with all this water vapor in the stratosphere, but what typically happens is that you see an environment where the polar vortex rapidly intensifies and strengthens, and it pulls the polar jet stream northward. And during El Nino years, this becomes enhanced. So this is why typically during El Nino years, and even into the start of winter, we have this relatively warm pattern. Typically with El Ninos, and I'm going to tell you this right now so that way I don't have to hear about winter canceled posts in December. El Nino winters always start off slow. The main event's always in January and February and then leaking into March. It's very rare, so consider it bonus snow if you see anything in December. Historically, actually for us, it's very rare to get accumulating snow because of the warm waters off of our coastline. But on average, El Nino winters always start off in January and February. They're considered second half winters. You know, they really make a comeback. So that's why you typically see warm falls because of this process. Let's see, Rob Allen. Sorry to hear about Norman. Was curious your thoughts as to why our models have been having so much trouble handling the pattern lately. Well, the problem that we have is that we're dealing with a lot of moving factors because, and we're going to see this all winter. With La Nina seasons and neutral seasons, but mostly La Nina seasons, the subtropical jet stream is weakened to a point that you don't see a lot of interaction between the two jet streams. So the amount of volatility and unknown and chaos is reduced. In El Nino, it spikes because now you're dealing with short waves in the subtropical jet stream and the polar jet stream. And you're dealing with the timing of these short waves interacting. Now, while these short waves are interacting during this time of year, throw in tropical lows. Tropical lows are just a nightmare on itself for a forecaster because tropical lows are really more of a mesoscale forecast. And what I mean by that is that you have a lot of small scale features interacting with these warm core lows. So you get a little bit of dry air that really wasn't forecasted very well because we missed some observational data. That could tear apart a warm core low and change the entire forecast and change the moisture transport and how this storm transitions. So this leads to a lot of chaos, and so that's why you always have to be on your toes. with these forecasts. So that is certainly, but overall, I have to say, overall, I think that the models have been performing pretty well. You never want to lock in details 5 days out or anything like that, but you kind of get a pretty good idea on the theme of the pattern. So I've been pretty happy with the model guidance in terms of understanding the themes. What you don't want to do, and I'll put it like this. The models overall, if you look at the encompassing, you kind of get the theme, right? But with the theme, you're going to get some of these models spitting out some insane ideas. And the reason why they're doing that is because one model run takes an interaction and performs a different way of getting about a solution with that interaction. So what you want to do is develop your game plan and give yourself goalposts of what to expect in this pattern, what's reasonable. So if you give yourself those goalposts, then you know which guidance you should be able to take out and say, okay, this solution is far more realistic than another solution. So if you do that, then you'll be able to weed out those insane solutions and say, okay, it had a bad run, throw it out. Let's look at the ensembles. Let's look at some of the GFS. We'll mix that in, throw it together, mix it together, throw it in a bowl. There's your forecast. Impressive cold air building up at 850 millibars and 700 millibars. Yes, especially over the North Pole. Let me see if I can pull up some of that data here while I'm here. Let's see here. Okay, 850 temperatures. Okay, this is pretty cool. 1, 2, 3. Look at that. That is a pretty good polar air mass building. It's expanding, it's growing, it's getting its act together, and it's going to allow for some snow development. Now, there's some model guidance that would suggest that the pattern over Siberia might get a little bit mild towards the middle of the month in Siberia on the GFS. European doesn't exactly follow suit with that, but we'll see how that all evolves. But certainly a pretty impressive polar air mass is building here over the Arctic and over towards Greenland and of course around Siberia. So we're well on our way. So fall and winter is coming, that is for sure. Are you buying the theme of a massive trough of below normal temperatures dropping south around the 8th with a trough axis on the GFS? I don't. I'll put it this way. It doesn't line up with how the pattern's evolving. I think the GFS is too fast in that evolution and too amplified. And to trust it, you'd have to ignore all the other observations. So what I would say is that I'd have to see some changes in the observations, i.e. the way that the polar vortex is forming. I'd have to see some sort of more stretching involved, and that's starting to influence 100 millibars and then 500 millibars. Right now, I don't have any indication of that happening, so I'm not exactly focused on it, let's just say. I don't, sometimes, like I said, sometimes a model produces a dud. What is the potential for flash flooding and flooding given how it has been over last week? It's high. I'm very concerned about flash flooding Thursday night into Friday morning, especially urban flooding around northeastern New Jersey, New York City. It could be pretty nasty. So definitely use some caution, take some time, and definitely be careful. Can you give us a quick crash course on what an east-based versus west-based El Nino could mean for winter weather? I always just assume when you hear El Nino for winter, it means warm and rainy for us all winter. Some of the snowiest winters that we have had in the northern mid-Atlantic have been El Nino winters. So that's the first thing. A lot of people, and this is because I have to admit, sometimes the news, they think that El Nino or La Nina is all or nothing, and it's not. It's only one piece of a very complicated and volatile puzzle. Pattern puzzle. There you go. When we're talking about East Base and West Base El Ninos, what we're essentially talking about is where is the convection happening. A lot of people focus in on West Base El Ninos and automatically connect it to active above normal snowfall years because you have a lot of convection on around the date line. And we know by research from Cosin and Ussolini, you can check that out under Northeast snowstorms. Here we are, this book right here, which is kind of the Bible for all nor'easter weather fanatics like myself when I was a kid. We know based on that research and that analysis that when we have a lot of convection around the date line, that it supports an environment favorable for winter storms. We also look at this for La Ninas when we have an east-based La Nina. Why are we focused on that? Because the coldest water is focused more towards South America. You have some warmer waters around the date line, convection, but not as strong. So when you have an east-based El Nino, your warmest waters are locked in towards South America and to the south and east of Mexico, and what that south and west of Mexico, should I say? And what that does is focus a lot of your convection to the south and the southeast of Hawaii. So because of that, your pattern is displaced, and what you end up with is a lot of storm development out towards the western Atlantic. We miss out, and you end up with either a lot of storms in the subtropical jet stream able to race out ahead of the polar jet stream, leading to warm patterns and wet patterns, and then the cold air rushes in. So you get a rainstorm, then it gets cold. Rainstorm, then it gets cold. So that's what you see when you set up with an east-based El Nino, unless you have other factors that can overwhelm that, like a significant disruption of the polar vortex, for example. With a west-based El Nino or central-based, basically what we're looking for is what I was just showing, convection around the date line. So when you have that focus setting up, and if it stays established, it's one piece that falls in place, and if every other factor comes together, then you open up your potential for a very interesting winter weather season. With that being said, El Ninos typically focus a lot of storm potential. Notice I'm not saying snow. Storm potential towards the mid-Atlantic, and not so much towards New England. So if you're focused on, like, let's say ski season, not exactly the best scenario for you because your storm track is further south. So it's harder to get those snowfall events. But if you're in Washington, D.C., Philadelphia, southern New Jersey, Philadelphia, and sometimes New York City Metro, game on for storms. Now, if you get cold air worked in at the right time, you get your high latitude blocking, everyone's happy, at least snow lovers. Not so much if you have to drive in it or whatnot. But that's why. So that's the basic reason why we focus on these things. What you don't want to do is consider this as an all or nothing proposition. A lot of people do that, and it ends up blindsiding you. Granted, seasonal forecasting is very difficult. It has a harsh track record. Sometimes you nail it, and sometimes you get kicked in the lower regions, and you just get a complete bust. You know, it's a very difficult because you're dealing with so many moving factors and so many features that can change the forecast in a pinch, that sometimes the easiest thing to do is not do a seasonal forecast at all. I know a lot of people are doing that. They're like, you know what? It's too difficult. They use an excuse of like, oh, climate change makes this almost impossible, which I think is just a cop out. But it's hard. Like if you go in this thinking you're the best in the world and you're never going to be wrong, you try to do seasonal forecasting, you'll be humbled real fast. So it's always a challenge. So this is why I never do like snowfall forecasts, like seasonal, like, oh, you're going to get 48 inches of snow in this location for the season. I don't know that. All you need is 2 winter storms and you're right. So what? The whole winter, nothing happens, and then you get 2 storms that drop 20 inches each, and then you claim verification. Really? So that's why. Private snow plow and cleanup contractors desperately need snow this year after how bad it was last year. Oh, I agree. I agree. My thing is that I don't want to make promises I can't really produce. A lot of snow contractors, they've always said to me, I need a snowy season, like as if I can actually produce it. I can't. I don't control the weather. Honestly, I don't. I really don't. If I did, I'd actually help the Mets quite a bit this year. But all I can tell you is the truth. And the truth is that I like the idea of a stormy winter. I just don't know if there's going to be cold air to work with. We'll see. Well, let's take a look at what YouTube is doing here.
A lot.
Oh, holy smokes. I noticed went through Ophelia, the barometer pressure remained very high. Why did it rain with high? Well, I don't know where your barometer. My barometer was not high. I don't know. It kind of depends where you're at, and what the barometer was. Is it supposed to be raining on Saturday? No. Well,
A lot of people want to know about Saturday.
why? What's on Saturday?
Different people have outdoor events
Oh.
they go to.
Okay, Saturday, if you're on the immediate coast, a few pesky showers, but not a washout. In the morning, you have your best potential for showers because your storm's pulling away. Afternoon, you're going to be clearing out, but it will be breezy, so be prepared for that. That wind gust is going to surprise a couple people, especially on the north side of Long Island, coming off of the Long Island Sound. Watch out for that. Let's see here. Tell me the rain will be done on Saturday. Wow, everyone.
Yeah.
So, you know what it is? It's soccer season, playoff baseball, weddings, and football. All that, right. So, yeah, that makes sense. Saturdays in the fall could be pretty crazy, I guess. Let's see here. By the way, when we got married, I remember this. The wedding planner, or something of that nature, was like, why don't you have an outdoor wedding? And I'm like, I'm a meteorologist, okay? And she's like, so? And I said, okay, I forecast the weather. I guarantee you, if I try to do an outdoor wedding in October, not only will it rain, but it'll probably like snow and sleet too. There's no way that I do an outdoor wedding in October during nor'easter season. That's just asking for trouble.
And our wedding day was gray,
windy, and
rain.
wet. Yeah, and they wanted us to be outdoors. I'm like, you're out of your damn mind. This Saturday, the best potential for rainfall will be in the morning along the immediate coast and around Long Island. As you get into the afternoon, it dries out and it's pretty nice, but it's going to be breezy. So don't be prepared for wind gusts around 30 miles per hour. So if you have any outdoor activities and whatnot, I definitely would prepare for that. If you have like any tents or anything like that. Sometimes the influences from strong external events tend to override other telekinetic patterns in the Pacific, Atlantic, etc. Is there potential for that happening in the upcoming winter? There's always that potential. When you're doing seasonal forecasting, this is why I always wait. I don't put things out way too early. I know everyone wants to be the first. But you have to study how are the different features interacting with each other. And if you don't do that legwork, then you're not going to understand what the dominating features are. Now, this El Nino is going to be strong. There's no doubt about that. But is the strong El Nino working with the rest of the pattern or counteracting the pattern? That's what you have to study. And that's why we're keeping an eye on where convection's happening and all that other stuff. Hard to believe that with El Nino you won't see more Miller A's. Also, you have to think that not all these storms will come up the coast with no cold air around. Well, we don't know that. There's so many factors to consider. Obviously, you're going to have Miller A's, you're going to have Miller B's, but there are way too many factors to consider before even breaking down a storm track. So I'm not really worried about that's like way out there. Okay, storm tracks for like a week can be influenced by so many different factors that we don't even know yet. Previous storms, current snowpack state, orientation of troughs, orientation of individual short waves, location of air masses, the density of air masses. I wouldn't even bother. Anyone that's telling you they know the storm tracks, what the storm tracks are going to be from a week-to-week basis out through January and February is full of it. Okay, I think I answered a lot of the questions about outdoor stuff. Like I said, definitely be prepared for the wind. I'm not so much worried. I think the bulk of your rain is going to be on Friday morning. If you're in Connecticut, Friday afternoon. But I think Saturday you'll be clearing out. If you were in, like let's say Rhode Island and Massachusetts, then I'd probably be a little worried. Will it be wind-driven rain like last time? You know, within that heavy band that I was discussing, it will be windy. When is the winter forecast coming out? Likely sometime in the end of October. I'll provide a date when I get a better idea on writing everything. How does the very warm North Atlantic and Western Pacific around Japan affect the overall pattern, or is El Nino the main player? They all are factors, and they all come into consideration, which again is why I wait a little bit to do the winter forecast. The warm northern Pacific is pretty much what you would expect with an El Nino state. You have a positive PDO developing. The warm Atlantic is a interesting factor because it enhances the development of cyclogenesis or storm development along the East Coast. So it enhances the potential for below normal heights to the south of Greenland and enhances the potential for above normal heights around Greenland. So it sets up blocking potential at the surface on up to the mid-levels. Whether that continues on up, don't know yet, because you could have stratospheric factors that overwhelm that and negate it. So we don't know yet. Am I concerned with the cold pools south of Alaska and Northwest? No, that doesn't surprise me at all. If you're having storm development, you're going to have movement of the strong winds, and as a result, you're going to get some cooling of the waters. Same thing as when you have a hurricane passing over the Western Atlantic. Initially, you're going to get some cooling waters because you have upwelling. The question is whether that's sustained, and that's why you don't just study the surface, you study the subsurface, because if you study the subsurface, you understand the potential of the sea surface temperatures and where they're going in the seasonal forecast. Can't wait up for the... You know what? The one thing I don't do is wait up for models anymore. I'll tell you that right now. I can't do it. It's part of being in your 40s, I guess, you know. I can't stay up that late. I can't do it. You know?
Your day starts very early.
Well, yeah, I mean, I start at like 4 or 5 a.m. in the morning. But yeah, I can't do like I can't do the old days where I could be up to like midnight and then wake up at 4 a.m. I'm like, I'm fine. I'm like, no. Now I wake up and I'm like, shoot me.
You do that when there's actually like a snowstorm actively going on.
Well, yeah,
And
when
then
there's
you
a
crash.
when there's a snowstorm going on, I'm just running on pure adrenaline. Let's see here. Okay, Hockey X is a question. Assuming you are starting to work on your winter forecast, I am. Can you give us your early thoughts for temperatures during late fall into December? Overall, I know late fall is going to be near to above normal. I'm pretty confident about that. Like I said earlier, El Ninos always start off winters slow. But the one thing that has my eye is that very cold air mass that's setting up already, the polar air mass building over the polar region. Excuse me, polar regions. That certainly has my attention. But as it stands right now, I like the idea of falls being generally warm, and that's playing out pretty nicely. Actually, it's already 9 o'clock. What do you know?
I figured you realize that.
Well, we've actually had a lot of
I
great.
realize by now that you forget to look at the clock.
We actually had a lot of great questions. This has been a lot of fun, but it's time to go to bed. No, just kidding.
Sort of.
Sort of.
Close.
Close to it. Definitely get ready for the next day. But I want to thank everyone for a wonderful night. We actually had a lot of great questions. This has been great. We'll see how this storm evolves. Of course, tomorrow morning we'll have more updates on the evolution of this storm. And I think for now, we will call it a night. And I will see you all next week. In the meantime, stay safe out there.